Very good day to my panelists, Professor Madhya, Dr. Nora Shikin binti Matisa, and Dr. Muhammad Faisal bin Muhyiddin Bacha. I am Sathis Anaraki Rajah, metric number AD170186, under the supervision of Dr. Nora Fitra binti Nasir, going to present on my bachelor degree project 1, which is the effects of inlet velocity of a bubble column reactor on the fluid flow pattern for biodiesel production. Okay, this is the content for my presentation today. I'm going to talk about the background study, problem statements, objectives, scope of studies, significance of my study, literature review, and also methodology. Okay, first of all, the background study. Fossil fuels are the main energy source in the world, and their overexploitation has resulted in the depletion of the source. This creates an awareness to find an alternative source to replace this non-renewable energy. Biodiesel is a renewable energy source or a biofuel which is free of sulfur and polycyclic aromatic compounds and also emits 40% less of carbon monoxide and sulfur dioxide compared to petrol diesel. Malaysia is one of the main producers of biodiesel, which accounts for 17.6 million tons of crude palm oil and 2.1 million ton crude palm kernel oil in 2009, which makes the palm oil industry is the fourth largest revenue sector in Malaysia in the year of 2009. Okay, the problem statement in my thesis is selecting wrong inlet velocity will decrease the efficiency of biodiesel production. This in turn could increase the production cost of biodiesel. This is due to different velocity because they will have different fluid flow pattern which will alter the rate of production. Okay, next, the objectives. Basically, this study is carried out to fulfill the following objectives. First of all, my objective is to study the effect of various inlet velocity on the fluid flow pattern in a bubble column reactor or trans-esterification reaction. Secondly, to study the fluid flow pattern in a bubble column reactor for trans-esterification reaction. Thirdly, to simulate and analyze the fluid flow pattern using CFD in ANSYS Fluent software. The scope of my study. This design is focused on, first of all, designing a bubble column reactor with two different obstacles using SolidWorks 2019. At the same time, this research will also focus on testing, simulating, and analyzing using ANSYS Fluent for three different inlet velocity in the bubble column reactor, which is 3, 4, and 5 meter per second. The temperature for the reaction will be fixed at 523 Kelvin for the whole testing. Thirdly, the project involves analyzing the fluid flow pattern of the bubble column reactor for trans-esterification reaction with the results obtained. Okay, the significance of my study. This thesis is to determine the fluid flow pattern due to various inlet velocity in a bubble column reactor. Next, this thesis is also carried out to analyze the fluid flow pattern using CFD simulation. The trans-esterification reaction in biodiesel production will also be studied. Okay, next we will be moving to the literature review. Okay, I'm going to explain about the trans-esterification process. Okay, what is the trans-esterification process? This is the process to synthesize biodiesel in which 1 mole of triglyceride will react with 3 mole of methanol, which will produce 3 moles of fatty acid methyl ester, or we'll call it FAME, and also the byproduct glycerol. Normally, this process will be carried out at a temperature of about 60 to 70 degrees Celsius and at atmospheric pressure for about 90 minutes. Okay, separation process of the biodiesel produced with the glycerol. Okay, both of them can be separated using precipitating tank and simple centrifugation. Methyl ester will be neutralized and separated from impurities by vacuum distillation and then washed with water. And then acid will be added to neutralize base catalyst if there is any base catalyst used in the process earlier. And then the process will also produce soap. The washing process will remove the salt produced, the remaining catalysts, soaps, methanol, and free glycerol. And then the water from the washing process will be then distilled off by vacuum. Okay, for the bubble column reactor. I'm going to talk on the design and working condition. But the bubble column reactor is normally in cylindrical shape vessel and has a gas distributor at the bottom. It is normally works in a condition of 2 to 18 megapascal for catalyzed process, whereas 2 to 30 megapascal for non-catalyzed process. And this temperature will be in the range of 373 to 593 Kelvin. Okay, what is the working principle of the bubble column reactor? The vegetable oil or palm oil will be filled in the bubble column reactor earlier, and then superheated methanol vapor will be blown into the column. This will produce a fatty acid methyl ester, which is the FEME, and also glycerol as the byproduct. Okay, this is the fluid flow pattern due to various velocity. The inlet velocity will affect the gas holdup in the trans-esterification process. When the velocity increases, gas holdup increases. This will cause small bubbles form to increase in churn turbulent flow regime. When the flow of liquid in the bubble column reactor are turbulent, it will increase the mass transfer. So this will indirectly increase the rate of production of biodiesel. Okay, I'm going to move on to the methodology. Okay, my research thesis starts off with the defining problem statement, and then identifying the objectives and scope of studies, and then conducting literature review. After that, we will move on to methodology, which is carrying on simulation approach. Okay, first of all, parameter will be selected for designing bubble column reactor, and then the bubble column reactor will be modeled using SolidWorks 2019. After that, the modeled bubble column reactor will be transferred to ANSYS Fluent 2020 R2 for further CFD simulation. Under the fleet simulation, we will carry on meshing, and then we will follow by setting boundary condition for the meshing process. When the result obtained, if the parameters satisfy the results, and we will analyze the results and conducting discussion. Okay, next, this is the designated bubble column reactor using SolidWorks 2019. As we can see, there is two barrier in my model. The inlet pipe is the smallest diameter, and then the outlet pipe is the bigger in diameter. Okay, below are the parameters I have mentioned in the slides. Okay, for the fluid analysis, this will be carried on in the ANSYS Fluent software, in which meshing will be carried out. Meshing can generate a high efficiency analysis when the mesh is rectified. A finer mesh will show a very accurate flow details because higher number of nodes and elements on project the result very precisely. Okay, these are the boundary conditions for my methodology. Okay, that's all for now. Thank you.